Hello students. So continuing our MCQs on electric charges and fields. So next 11th one. So coordinates of a square he has given. If electric field is 10 volt meter along z axis, then electric flux through the square face is. Now if you observe the coordinates, z coordinate is 0. So there z coordinate is 0. So now I will plot the points. So we can have the square minus 1, 1. So somewhere here I will take minus 1, 1, 1, 1. So it will be in first quadrant. Minus 1, third quadrant. And 1 minus 1 you will have in fourth quadrant. So if you join these 4 points, you will have a square. You will have a square. And this square is in xy plane. This square is in xy plane. Now, if you apply distance formula and measure this length, so side you will have 2 meters. Side you will have 2 meters. Now, E is acting along z axis. So if I take E is along z axis, that is of 10 volt per meter. Now if you draw normal to this surface, if I take normal, so normal will be also along the z axis, so you have theta equal to 0. Now you can calculate flux. So phi is equal to E cos theta into ds. So E has given 10. So theta is angle between E and normal to the surface. So E and normal are parallel, so theta is 0, cos 0. Area of this square. So area of this square will be 2 into 2, you will have 4 meter square. So if you simplify, cos 0 is 1, 10 into 4 is 40. So you will have 40 volt meter. So option A is our answer. Option A is our answer. Next, 12th one. E1 is electric field on the axis of a small electric dipole at a distance r, and E2 at same distance at an angle 60 degree. So if I take dipole minus q plus q, if P is a point at a distance r making an angle theta along the axis of a dipole, then electric field at point P is given by K P by R cube root of 3 cos square theta plus 1. 3 cos square theta plus 1. Now if you take these two cases, distance is same, P will be constant, K is constant, so I can say E is proportional to root of 3 cos square theta plus 1. Now if I take E1, so for E1, so it's on the axis of a dipole, so on the axis means theta is 0. If you take E2, theta he has given, so theta 2 is equal to 60 degree. You are required to find the ratio. So now I will take ratio. E1 by E2 is equal to root of 3 cos square 0 plus 1 divided by 3 cos square 60 plus 1. Cos square 60 plus 1. So now simplify this, you will have the answer. So root of cos 0 is 1, so you will have 3 plus 1. Cos 60 is 1 by 2, so square means 1 by 4, so 3 by 4 plus 1. So this is equal to root of 4 into 4 divided by 7. So if you simplify, you will have 4 by root 7. 4 by root 7. So option A is the answer. Option A is the answer. 13th, a particle of mass m, charge q, is thrown with speed u against the uniform electric field E. So he says against. You are required to find distance traveled before coming to rest. So initial velocity he has given it as u. Finally it comes to rest means final velocity is 0. Against means acceleration will be negative. A is negative because it is against the electric field E. You are required to find a distance traveled. So if we use basic formula, that is v square minus u square is equal to 2as. So if I substitute, this is 0 minus u square, acceleration is negative, so minus 2as. So we know that a is qe by m, so minus 2 qe by m into s. So minus gets cancelled, so you have u square m divided by 2q into e is equal to s. 2q into is equal to s. So option C is our answer. Option C is our answer. Next one. The charges q, 2q, 4q are placed along x-axis at a distance from origin. So if I take axis, so I will take axis. Now origin, so origin 0. Charge q, it is placed at a distance r. Charge 2q, it is placed at distance 2r. Charge 4q, it is placed at distance 4r, and so on. So if you observe, all charges are positive. So total electric field will be summation of this. So E1 is due to Q and E2 I will take due to 2Q, E3 due to 4Q, and so on. So electric field at origin. So at origin, it will be summation of all the electric fields E1 plus E2 plus E3 so on. So this is equal to K I will take common, that is 1 by 4 by epsilon naught. So first it is Q by R square plus, if I take E2, it is due to 2Q, 2Q divided by 2R bracket square plus E3, 4Q divided by 4R bracket square plus so on. Now simplify this. So K I will write it as 1 by 4 by epsilon naught. In all the terms I can take Q by R square common. So here remains 1. So here it is 2 by 4 plus here it is 4 by 16 plus so on plus so on. So this is equal to 1 by 4 by epsilon naught Q by R square. If I simplify 1 plus 1 by 2 plus 1 by 4 plus so on up to infinity. Now this bracket is in GP, so apply S infinity formula of GP. S infinity is given by A divided by 1 minus R. So if I apply that, 1 by 4 pi epsilon naught Q divided by R square. So A is 1 divided by 1 minus 1 by 2. So we'll have E net is equal to 1 by 4 pi epsilon naught q by r square. So if you simplify, you will have 1 minus 1 by 2 is 1 by 2. 2 will go to the numerator. So you will have 2 by 1. 2 by 1. So this is equal to 1 by 4 pi epsilon naught 2q divided by r square. So now if you observe the options, so you have option B is the answer, 2q by 4 pi epsilon naught r square. B is the answer. Next one, a hollow metal sphere of radius r is uniformly charged. So there is a sphere which is charged uniformly. So I will take a sphere which is charged uniformly. I will take it as plus q charge on it. The electric field due to sphere at a distance r from center. So I will take center as O. You are required to find electric field from the center. So we all know that electric field inside a charged conductor is 0. So E is equal to 0 till it becomes equal to R. Up to radius E is 0. So option A is not the answer. Option D is not the answer. So 0 as R increases for R less than R. 0 for R increases for R less than R. Now outside the sphere we know that E is inversely proportional to R square. So you can say as R increases, E decreases. So as R increases, E decreases. Now check whether B or C. So and decreases as R increases. So option B is the answer. So as E decreases as R increases for R greater than capital R, that is radius. So option B is the answer. Next one. A charge Q is enclosed by Gaussian spherical surface of radius R. If radius is doubled, then outward flux. So in previous questions, we have seen that flux does not depend on the Gaussian surface. Now here there are charges, we may say Q1, Q2 plus Q3, so on. So there is a surface enclosing all these charges. So outward flux. Now even if the surface increases or decreases, the flux coming out of this remains same. So it does not depend on the size. So flux remains the same. It just depends upon charges that it is enclosing. It depends upon the charges enclosed by the Gaussian surface. 17th, an electric dipole having dipole moment P is lying along the uniform electric field. Lying along the uniform electric field means theta 1 is equal to 0. The work done in rotating the dipole by 90 degree, so theta 2 is equal to 90. You are required to find work done. So work done is given by P into E cos theta 1 minus cos theta 2. Now substitute. So we'll have PE cos 0 minus cos 90. So cos 0 is 1, cos 90 is 0. So PE 1 minus 0. So we'll have P into E is the work done. So work done is P into E. So option D is the answer. Next, 18th. What is net charge on conducting sphere of radius 10 cm given that electric field 15 cm from center of sphere is equal to and is directed inwards. So there is a sphere, electric field is directed towards this sphere it means that sphere is negatively charged. So by this you can remove these two options, C and D will not be the answer. Now 15 centimeter means point comes outside the sphere. So if I take formula of E is equal to K, Q divided by R square. Now I'll substitute. E is electric field is 3 into 10 raised to 3. K is 9 into 10 raised to 9. You are required to find Q. R is 15 centimeters. That is 15 into 10 raised to minus 2 bracket square. You have to convert it into meters. So now if I simplify this, I will be having 3 into 10 raised to 3. 15 square, I will write it as 15 into 15. 10 raised to minus 4. This divided by 9 into 10 raised to 9, I will take to the LHS. This will be equal to charge Q. So now simplify. So if I simplify, 3 3s are 9, 3 5s are 15. So 15 5s are 75. So Q is equal to 75 into 10 raised to. So minus 1, 9 will go to the numerator, you will have minus 10. So 75 into 10 raised to minus 10, or you can say 7.5 into 10 raised to minus 9 coulomb. So option B is the answer. Option B is the answer. Next, 19th. A charge Q is placed at the center of line joining two identical charges plus Q. The system of charges will be equilibrium if Q is equal to. So in offline classes I had told. So if these two charges are Q, so at midpoint whatever charge will be there, it will be 1/4 of this with the negative sign. So 1/4 with the negative sign. So option C will be the answer. Lastly, you are required to write SI unit of epsilon naught. You are required to write SI unit of epsilon naught. So you take a formula which contains epsilon naught. So here we are taking Coulomb's law. F is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. So epsilon naught is equal to 1 by 4 pi, it is constant, Q1 into Q2 by F into R square. F into R square. Now substitute the units of this. So Q1 into Q2 means you will have Coulomb square. Force is in denominator per Newton. Distance is also in denominator, so you will have per meter square. So Coulomb square per Newton per meter square. So C is the answer. Clear, students? Again, other MCQs will take in next video.